Welcome to today's lesson about the binomial distribution. You'll notice I'm already starting in Excel because binomials are very Excel heavy. You will not be able to survive binomials without Excel. There are several different types of questions that you can be asked in a binomial question. In this example and the next example, I've tried to hit all the targets almost, I think. Many of the questions are going to ask you what is the probability that something happens. And you can see with these first three questions here, that is exactly what they ask. When it asks you for a probability, I would encourage you to start setting it up using inequality notation. For example, for part A, it's asking for the probability that a student answers 4 questions correctly. Is it equal to 4, less than 4, greater than or equal to 4? In this case, it's equal to 4. Equal to is a very special case. It's the only one that doesn't have a greater than or a less than. And when you see that for binomial questions, and we're going to be using the binom.dis.range command. There are other commands, but I would say, generally speaking, this is the easiest. It's going to ask you for n, and we have 10 questions. It's going to ask you for the probability of success. Now, we actually have to calculate that in this question. If there are 5 choices for each question, then we have a 1/5 or a 0.2 chance of getting it correct. And as I said, equal to is the special case. When it is equal to 4, just use 4, 4. If it's equal to 7, use 7, 7 at the end. To save me from going back and forth between all of these, I'm going to go ahead and proceed to part B, and I'll come back and actually type this in to Excel in just a minute. Part B, the probability the student scores at least a 70, that is, they get at least 7. So we have X and 7, and at least is a greater than or equal to. Now, this is not one of the special cases, so I would argue that you want to make it look like this. So if X is greater than or equal to 7, the smallest X can be is 7. Now, it doesn't give me a number at the top, but the most number of questions that I can answer correctly in this example is 10. So it won't always be 10, but it'll be whatever the n value is in this particular question. So this would be binom.dist.range would be still 10, 0.2, but this time it would be 7, 10. Part C, the probability the student gets at least 3, but fewer than 7. So it's going to start looking something like this. So at least 3 is less than or equal to, and if you're saying no, you just told me at least and the previous question was greater than or equal to, notice we have X is greater than or equal to 3 going in the reverse order. And then fewer than, so that's less than. Now that's almost what I want, but it's not quite because I don't like that less than. I want it to be less than or equal to. For binomial distributions, if you are less than 7, then you are at most 6. Notice, because it's binomial, you can't be 6.5. You can't be 6.9. If you're less than 7, you must be at most 6. And again, it's still 10, 0.2, and this time it would be 3, 6. So let's try doing those 3, and we'll come back and do the last 3. When I'm doing multiple calculations, I like to label mine in Excel. So I'll just label this X equals 4 for part A. Of course, you could label it part A too, but that you might not know if it's number 5 part A or number 7 part A. So we have the binom dot dist dot range, And it asked for the trials, and we said there were 10. It asked for the probability underscore S, which is the probability of success, or 0.2. And then it asked for the two numbers, and for the case of A, it was 4, 4. So our answer to part A is 0.0881. So for x greater than or equal to 7, we have binom.dis.range again. And again, it's still 10, 0.2. But this time for part B, it was 7, 10. So we get 0.0009. So we get 3 less than x less than 7, less than or equal to x less than 7. And even though I wrote 7 over there on the left, notice we're using 6 because of that inequality. So that's the great binom.dis.range command. I'm going to leave 2 spaces for the mean and the standard deviation that are coming up. So for part D, how many questions should they expect? And expect is a nice keyword telling you to find the mean. Oops, and I'm gonna, because I know I'm gonna run out of space, I'm gonna move these. I thought they were at the top. Now we could create a probability distribution and then use our formula from 5-1 to find the mean, but that is definitely the hard way. For binomials, the easier way is to remember that the mean is n times p, or in this case 10 times 0.2, or 2 questions correct. And then for the standard deviation, again, you could create a distribution. You could use the formula from 5-1. That is definitely the harder way. The easier way is to remember the square root of npq. So it's 10 times 0.2, and q would be 1 minus 0.2, or 0.8. And just to show my work in Excel, even though I did it in my head, the mean was 10 times 0.2, and the standard deviation, the square root of 10 times 0.2 times 0.8, or 1.26 questions correct. And that leaves us with the last question. Explain why this is a binomial experiment. There are 4 requirements to be a binomial experiment, but when they ask you to explain or justify or whatever verb they use, you need to do so in the context of the problem with those 4 requirements. So the first requirement is there had to be a fixed number of independent trials, but I don't want to hear you use the word trials. In this case, trials is questions. And instead of saying fixed, I like to go ahead and say what that fixed number is. And instead of saying trials, we say questions. And they're supposed to be independent, and we're told they're independent here because he guessed randomly. And then there are two possible outcomes, success or failure. In this case, you either get the question correct or you get the question wrong. The probability of success, but don't use the word success, we're going to say answering correctly. And instead of saying it's constant, I like to say it's always, and in this case I would say 0.2 or 0.2. So I know not only that it is constant, but I know what number it is. And the last one is we will count the number of correct questions. One way that you can know a question is binomial with not necessarily going through all these 4 steps is to check to see if you can find an n and a p. And I mentioned in the first bullet point, I like to use the number 10 or whatever the appropriate number is to say that is the fixed number of trials. And that's the n. And then in the third bullet point, I like to use the probability of success, or in this case, the 0.2, so that I know what p is. And if I can find n and p, it's usually, not always, but most of the time, binomial. Make sure you check out the next example for binomial problems. It's got a few more things that this question didn't have, but this is a really good question to get a good start on binomial distribution. As always, if you've got questions, just ask your instructor.